Hello students, welcome to Services classes, and now we will be discussing some problems regarding Jacobians. Okay, so your problem is like this. Okay, the Jacobians. Okay, show that ax square plus 2hxy plus 2hxy plus by square and capital Ax square plus 2hxy plus by square are independent unless a by a is equal to b by b is equal to h by h. Solution goes like this. Let u is equal to ax square plus 2hxy plus by square plus by square, then du by dx, let's go ahead. So we were till now we are here to so we have u is equal to x square plus 2hxy plus by square. So your du by dx becomes your 2ax plus 2hy, and then your du by dy, that becomes your 2hx, obviously 2hx plus your 2by, right? And then you are left with your x, your du by dz. Okay, so you have, and then v you have ax square plus 2hxy plus by square, right? So if we want to find the partial integral of du by dx, that is only with respect to x, then we have 2ax plus 2hy plus 2hy, and then you have dv by dy is equal to dv by what it will be. Okay, see, we have y only in two terms. Okay, 2hxy in by square, so your ax square becomes a constant, for that it becomes 0. So you are only left with 2hx, you don't have any other option, and then 2by, right? So now go ahead and then do it. U and v will not be independent. U and v will not be independent if there exists a relationship between them. If there exists, so there should be no relationship, that means relationship between them. Okay, and there is no relationship between them. Exists if there exists a relation. Okay, relationship between them. Now what you have to do is you have to so relationship between them, and in this case In this case, you have du by dy, duv by dxy they should vanish because we want an independent relationship. Okay, you should not have any relationship. So this is how these are Jacobians. I told you initially also these are Jacobians. So you have duv by dxy is equal to 2 into ax now dub dxy is equal to 2x plus hy, right? 2h x plus by, and then 2ax plus hy 2hx plus by, by, and that must be equal to 0. That must be equal to, that should be 0. So this implies that this implies that ax plus hy now the variables x and y are now the variables x and y are independent and such as coefficient of x square should vanish separately. Hence you have and these conditions also make the coefficient of xy 0. Hence h by h are the required conditions, are the required condition, and that's the required condition. Okay, let's go ahead with to another problem. Okay, and the problem is let's go ahead to another problem, and the problem is your mm, problem is your second one of this part. It says like transform the integral to Cartesian form and hence evaluate the solution. We have zero to pi, 0 to a, r cube sin theta cos theta dr d theta, and that is equal, that is your 1, and then a region that is hence the region semicircle ABC of the integration is bounded by x-axis r is equal to a, that is your theta is equal to 0 and theta is equal to pi, that is x-axis in the second quadrant. X-axis in the second quadrant. So that becomes your like this, that gives us like something like this: r sin theta, r cos theta, t by dr, putting x is equal to r cos theta, y is equal to r sin theta, dx dy. Instead of taking dx dy is r d theta dr, r d theta dr. Okay, the dx dy is r d theta dr. So what you get is, see, these two diagrams are very important, but let me first do it. Okay, we get minus a to plus a, 0 to root over x y dy dx. So it's minus a to plus a and then x dx, 0 to root over y dy y dy So that's your answer. You have to keep in mind that these are the two diagrams which are very important for you to remember. Okay, this is your for d theta part. Your r is equal to a, the radius is a over here, and then this is your 0, this is your a, this is your c, this is your b, and here you have like this. R is your 2 cos theta, your theta is 0, on this your x is equal to 2, theta is here pi by 2, and this is your y dash, this is your y, and this is your x. Okay, and that's your answer. 0 minus a to plus a, this is equal to 0. That's your answer. Okay.